Thank you to all the speakers. And I'm just going to now ask that our final organizing member, Bob Woodward, who is the president of IRIS, give some concluding thoughts on the day. And oh, except maybe Eileen was jumping in. I can't remember. I'm so sorry.
Yeah, she's going to jump in at the end.
Okay, sorry, Eileen.
Great.
Thank you.
Okay, great. Well, thanks, Kasey, and thank you all the speakers. What a fantastic 4 hours of talks, really super. For those of you out there, I'm not sure as participants if you can see how many people were participating, but we were running about 220 to 230 people over the entire 4 hours. So really an amazing turnout. I think we've really with this subject of distributed acoustic sensing really found that the research coordination network effort has targeted the right topic, and that's great to see. I thought maybe I'd just recap a little bit of what we heard over the 4 talks, and I really want to credit Scott, Tyler, and Dante Fratta for putting together this program this afternoon and inviting the speakers. Really a nice flow. I thought that we started off with Latte Krazik's presentation on strain sensing in urban environments, and really talking about her motivation that we've heard over and over again over the last few hours about using sensor densification for improved spatiotemporal resolution, and really a key, a fundamental element. I also really liked her expression that the sensor is the fiber. And noted that in my notes. Not surprisingly, she gave us a case study. In this case, it was a case study in Iceland where they laid out fiber cable, they laid out geophones, they laid out broadband instruments. And we saw this and we came back to this theme at the end of the day with Herb's talk, where we're trying to compare DAS, which we're all trying to understand how it responds in the real world. How sensitive is it? How does it couple? How do these factors impact our observations? And we're trying to get traction on that by comparing the unfamiliar, the DAS observations, to the familiar, geophone observations, broadband observations, and so forth, and really trying to sort of bootstrap our way into fully understanding how these measurements compare to our traditional measurements, and then from there move on to the things that only DAS can do and our traditional measurements can't even make such observations. I thought it was interesting. Latte showed a comparison of travel time picks. She showed a comparison of spectra as a way to give us that familiarity with traditional observations or traditional analyses of point measurements and comparing that to DAS. And she finished up with a few key points that old cables are usable. It gives us many more sensors out there, or potential sensors to work from. That there's a broadband character to the records we observe with DAS, that it's not a narrowband instrument, and talked about using it in urban environments to detect hidden faults and other hazards in urban environments. And I thought that was really, really important. And that kind of nicely keyed to the following talk, which was given by Richard Allen on looking at the status and opportunities for massive sensing networks, and really talking about earthquake early warning. I liked Richard's presentation of kind of a, I can't remember exactly his term for it, but I'll call it a feedback loop between having a high societal impact application, which is driving additional observations, which is driving additional discovery, driving additional capability, which is in turn improving our ability to have societal impact with our science and our observations. And I think that's just so important. And he was talking about how the societal benefits in the West Coast of the United States, the societal benefits of densified seismic networks are driving the further densification of those networks. Richard talked a lot about using the MyShake app and using cell phones as a way of making massive observations, both massive spatially in terms of covering very large areas and very large in observations. I thought that was very interesting, really focusing on the sensing side of this whole earthquake early warning problem and how that can be addressed. He talked about, well, as I've already said, that massive sensing is the key here, and that clearly DAS fits into this equation beautifully because it gives the ability to have very dense observations over very large areas. We talked about the possibilities of using subsea cables for this. I thought that was interesting. I also thought tied into the subsea cable element was some of the discussion in Latte's talk about the ability to make observations even through amplifiers and other devices that are in the cables. And I think that if that seems to me a critical piece to utilizing long cable runs, whether they're on land or underwater, is that at some distances they're interrupted by various pieces of equipment. And to the extent that in some cases we can make observations through and past those devices seems to me to be really critical. I may be oversimplifying that. I'm sure I'm dramatically oversimplifying it. But the fact that we seem to be able to get through any kind of device at all would be really critical. And then Richard also talked about the ground motion and ground motion predictions and the critical nature of that, using the distributed acoustic sensing both as a mechanism for improving our understanding and sort of calibrating our ground motion prediction equations and prediction capability just through continued observations, both near in urban environments and near source environments, but also the viability of DAS as playing a role in this in the real-time evaluation of ground motion as the earthquake is happening, as the waves are propagating, understanding the actual ground motion and updating projections of what the shaking could be. I thought that was really critical. Then I really liked that next Carrie Ann helped us understand how we can get traction on this whole big data problem that we face with DAS, that it's her talk DAS and big scientific data analysis. It gave me hope that we can actually get traction on these giant data sets and the complex signals that they contain. I really liked her presentation of this kind of exploring this space of both large in and large time. And I think, clearly as DAS systems are connected up, we definitely, with existing cables and, really in many situations where we might put out DAS, we're likely to see very long-lived sets of observations because obviously once you've connected an interrogator, the cable's not going anywhere, it's safe, it's secure, assuming it's a buried cable or a telco cable. So we have the potential for making not just large numbers of measurements along the length of fibers, but having those fibers out for very long periods of time. So we really end up getting both large N and large T with DAS. Carrie Ann identified a number of the challenges we face with DAS data, but then after sort of scaring us with all the challenges, she presented a number of the algorithms and the approaches that we might use to get traction on the problem. Things from efficient algorithms, machine learning, high performance computing, trying to do various data reduction strategies to sort of beat data sets into shape, and so on. I really appreciated her explanations of the machine learning algorithms that might be apropos here and some of the strategies she's explored for making those algorithms very, very efficient. I found that interesting. The Q&A discussion with Carrie Ann was interesting because we explored not just what data science can do for those of us that are more observational focused, but talked about what us observational types can do to make the data scientist's job easier. And I really liked the whole discussion of bringing prior information to bear. And I think this was the first point in the whole afternoon when the term metadata came up and the importance of metadata to collecting DAS data and really understanding those data and just bringing physics into the problem, not trying to make our algorithms work any harder than they have to if we already understand some of the physical constraints and physical properties present in our observations. And then Herb finished out the set of presentations with some great field trials. Really enjoyed seeing those. I like the trial out on the frozen lake and getting the fibers coupled into the surface in just a weekend. That's quite impressive. I was thinking it'd be a lot more work than that. So that gives some really interesting options for cryo applications, whether it's on glaciers or other features. Potentially you're talking about a field methodology where the deployment of the sensor could be done quite rapidly, and yet you could get very, very large scale measurements. And that's indeed very exciting. And we are starting to see some of the first experiments, seeing data coming back from glacial applications and other things like that. And then I also enjoyed seeing the Garner Valley example with vibratory sources and really having kind of calibrated and known sources as a way of really testing out both the observations on the acoustic, distributed acoustic sensing systems, as well as the co-located geophones and more traditional sensors. So again, this whole idea of working from what we know, which is signals on geophones or broadband sensors, and using that to help us understand the signals on the new technology. And the comparison that Herb showed us between the geophones that were bracketing the observations along the fiber, the comparison of the waveforms from the geophones to the fiber truly was impressive. I think Herb said he himself was amazed that they got that kind of alignment in those observations. Pretty amazing. So I found that whole presentation to be sort of really this whole set of presentations to be all of a piece as we went through our introduction to the technology, looking at potential large-scale applications, looking at how we deal with the data and wrestle with the big data problem, and finishing up showing people actually getting out there, making these observations and showing us how well they work and what we can do with the data. So I think that made a great package. And I want to extend my thanks again to Dante and Scott for putting this program together. Couple other quick thank yous. I wanted to thank Kasey Aderhold for all of her work in helping set up this afternoon's virtual webinar or virtual workshop. Everything from Zooming and behind the scenes Zoom work to websites and helping all of us coordinate on all of these activities. And then I also want to thank Eileen Martin and Nate Lindsey. They were an integral part of putting this afternoon together. And I think that you'll see if you stay for parts 2 and parts 3 this week and the beginning of next week, that they have an absolutely first-rate hands-on data analysis program for you to interact with. They have put tremendous energy, tremendous thought and preparation into it, and I think you will find it's absolutely superb, those of us that have gotten a sneak preview. So 2 quick remaining comments. I just wanted to note that Research Coordination Network is about building a human network, a community of practice and a community of interaction around a given subject or a given line of scientific inquiry. And I really think we're on our way here. This is really our first public event for this new Research Coordination Network. I hope all of you will stay engaged in this as we go forward over the next couple of years. We have many more workshops planned. And for those of you that got excited about seeing Herb's field photos and would like to get out there and see some DAS data being collected yourself, the RCN will hold a field course. We're aiming for late next summer or fall. For this field course, we'll invite 40 or 50 people out into the field, and we'll be installing a whole variety of DAS systems and side-by-side with traditional seismometers and putting out all kinds of interesting geometries and basically getting our hands dirty and collecting some interesting data sets. And then that will be followed by a data analysis course where we will take that data set that we collected and actually subject it to a whole variety of analyses and interpretation. So stand by for more information on that over the coming year. And then before I turn it over to Eileen, I just wanted to remark that I thought this virtual workshop format worked out actually surprisingly well. Might have been maybe a little more interesting to be sitting in Breckenridge, Colorado right now, where we originally intended to hold this, and we'd all finish up and have a beer and go hiking. But I thought it worked well. I, for one, enjoyed seeing the questions rolling in because I could see many more questions than I would have heard if I was sitting in a traditional audience environment. And I could see all the slides really well, and I could hear the speaker really well. There were no distracting noises in the auditorium. So I thought that worked pretty well. So I was happy to see that. So thank you everyone for attending all afternoon. I'm going to turn it over to Eileen, who's going to give you just a quick few comments on the upcoming data analysis portions of this workshop.
Yeah, thanks very much, Bob. So we're really looking forward to days 2 and day 3 of the workshop. And so on day 2, we're going to be going through some Jupyter notebooks that are going to be run in the Google Colab system. So you want to make sure that you have a Google Drive account so you can log into drive.google.com with that ahead of time. You'll also want to go to check out the Jupyter notebooks. I'm putting the link here in the chat. And there's also a video that goes through the introduction of how do you open up these Jupyter notebooks in Google Colab. And if you can get through just the first couple of steps there, then you're golden for getting ready. But if you run into any difficulties, do ask questions on the Slack channel. Between now and then, we've got almost a dozen workshop guides and those of us that are organizing who are happy to help you with questions. So here's the link to the Slack again. We're also going to use that Slack for some of our activities during breaks next time for generating discussion there. And the other thing that we'll be doing is we'll use Google Drive forms for certain activities, and we'll use breakout rooms next time. So what that means is you're going to get to be grouped up with, maybe 4 to 6 other participants so that you can actually discuss the data analysis as you're working on it. You can have other people to interact with through the video chat and through screen sharing. So hopefully that gets it, more of that in-person feel that can be hard to replicate online. The other thing I want to remind you all about is on day 3, there's going to be some talks by some of our workshop guides, but there's also time for lightning talks. And we really want to learn about what the participants are doing. So I'll put this link to the Google form to sign up for that right here in the chat. And if you can sign up for that by, I think it was like midday on Saturday, then we'll announce Saturday evening who's going to be presenting lightning talks on Monday. And it's just, 1 to 2 slides, has to fit within a couple of minutes. So hopefully this gives a chance for us to find out about a much broader range of people's research. And if you're new to DAS, but if you really dive in on day 2 on the analysis and you start to find interesting features in the Forge dataset or the Brady Hot Springs dataset, we'd also love to see your slides for that. So we want to have some people with different levels of experience and different interest areas within DAS presenting on day 3, which is August 17th. So that's a week from now. I think that's it as far as getting ready for next time. So I guess this is the end of the call. All right. Well, thanks everybody. Looking forward to talking to many of you on Wednesday.